Very good morning to all of you, students. So we can continue our lecture, friction in solids and liquids of physics. Okay, and the last point which we want to learn, the application of Bernoulli's principle. We have already explained the Bernoulli's principle, how we have used in Torricelli's theorem. Then after that, venturimeter. Okay, so these are the main applications that we have learned. Then now finally we want to study the different applications. One of the applications for that is the how Bernoulli's principle is used in blood flow in artery. You know, artery actually carries the blood from your heart to the different parts of the body, because this carries the pure blood to the different parts of the body, and veins which carries the impure blood from the different parts to the heart, so that you know the function of that artery. Now sometimes what happens, you know how the Bernoulli's principle can be used in that artery. So there is some plaque, due to the plaque, there is a constraint is going on into that artery to carry the blood from heart to the different parts of the body. Plaque means that means layer has been deposited. Okay, some constraint is there, and that opposes to the flow of blood from heart to the different parts of the body. Then at that time, the heart has to do a large activity on that artery to flow that blood, and so therefore heart is giving external pressure to that artery, and the blood gets flow, that means through the artery. But now when the blood is starts flowing through that artery, now there is one external pressure is there on that heart from the externally, and inside, as the velocity increases according to equation of continuity, or velocity increases, or according to Bernoulli's principle, the immediately pressure is going to be get decrease. And as the velocity increases, pressure decreases. So therefore what is going to happen, so outer side pressure is more, inner side pressure is less, and so therefore there is a collapse of arteries going on due to that low pressure. Again heart has to do the large activity, so this is the first stroke. Then the second stroke, again heart is doing the large activity to flow the blood inside that artery, through the artery, and so therefore when it causes the pressure on that artery, then again the second time that blood starts flowing with the very large velocity, and so velocity increases, pressure is goes on decreasing, and this is the way, that means how there is a flow of blood is going on in the artery, but there will be a second attack, and that is also we can say that heart attack will take place, because of there is a plaque constraint into that your artery. But here according to Bernoulli's principle, velocity increases, pressure decreases, so that things can be happens. Okay, so heart exerts further pressure to open this artery and forces the blood through it. Okay, as the blood rushes through the opening, the internal pressure once dropped due to the same reason and leading to repeat collapse. This may result in heart attack. Okay, so that things happens in case of the blood flow and artery. Okay. Now the second applications, that and the last application which we want to learn, that is wings of aeroplane or aerofoil. Okay, aerofoil. So now, sir, what is that? You know, in aerodynamics particularly, we are using the Bernoulli's principle. Okay, sir, how we can use the Bernoulli's principle? You know, there is some arrangement has been done to the wings of the aeroplane in such a way that the aeroplane, that is the best example of the aerofoil. Aerofoil and aeroplanes, that wings are the one and the same. Sir, how that constant is there? Means how that your shape has been made of the wings of the aeroplane or that aerofoil. Particularly this shape of the aerofoil is in such a way that upper part of the aerofoil or the wings of the aeroplane is the convex as compared to low part. म्हणजे मुलांनो हा वरचा पार्ट जो असतो तो असा कॉन्व्हेक्स असतो. ओके, and it is convex as well as lower part will be like this. Okay, means near about it is considered to be a concave, or we can say plane also. Okay, so this is the way how the shape of your aerofoil will be there. Okay, you see here, this is the way how the shape of aerofoil will be there. Okay, so now this part will be the convex above and concave below, or plane below the free surface. But one thing is very sure, that upper part is convex than that of the lower part. Then sir, what happens here then? How the aeroplane is going to get fly? Okay, that is the aerodynamics. So very simple, as this part is the convex, so therefore that air which is going to flow above the convex part. Okay, so then Okay, is convex part. Then the streamline airflow passes to the airfoil, it splitters into the leading edge but join again to the trailing edge. Okay, leading and trailing edge. Then what is going to happen? The streamline air above the convex shapes get crowded. Okay, when the air is going to flow, that means into that wings of the aeroplane, so aerofoil, then at that time what happens, all the layers of the liquid is going to get crowded here. So as they have been crowded near to that your convex surface, so therefore area will be goes on decreasing, and so therefore velocity of the air is goes on increasing. Okay, at near the convex surface particularly area decreases and velocity will be increases. So then what is happens here, according to Bernoulli's principle, this thing is going on. A1 V1 A into V will be remains constant. Means here as the area decreases, velocity has to be increased. So that is the Bernoulli's principle has been satisfied here. But sir, actually this is the equation of continuity. But how the Bernoulli's principle? So in Bernoulli's principle, as particularly we have calculated, so P plus that is your pressure, energy per unit volume, okay, plus okay your potential energy per unit volume plus kinetic energy per unit volume will be remains constant. So if I will take pressure energy per unit volume and kinetic energy per unit volume, 1/2 rho v square will be remains constant, because that means plus rho gh, so this is at the same height. So here in that case pressure will be, now here what is going to happen, you see here velocity of that air is goes on increasing near the convex surface, so therefore pressure has to be decreases, because height is the same, means velocity increases, pressure has to be decreases. So means the convex surface, the pressure has been decreases. Okay, here it becomes the lower pressure, of the air. And below that, as the streamlines they are going parallelly, so therefore here we can say that here in that case area will be the large, so therefore as the area larger, so therefore velocity will be decreases. As the velocity will be decreases, so therefore velocity decreases, here pressure will be goes on increasing, means here it has the high pressure, okay, low pressure, high pressure below the convex surface. So now what happens, you see here in the wings, below that there is a high pressure is there, here that pressure has been reduced, and so therefore due to the pressure difference, okay, so here atmospheric pressure and pressure difference, what is going to happen here, the wings are getting the flight, and so that flight is also, that means lifts to that, okay, this that lifts to that your plane in the upward direction, and that flight is also lift is also called as dynamic lift, that is the name for that is dynamic lift. Okay, so here in that case what is going to happen, so as the pressure is going air is going to with the very high velocity at the convex part, therefore pressure decreases, and below that there is atmospheric pressure, and that pressure will be higher as compared to, that means your upper pressure, lower pressure is higher and upper pressure is lower, and so therefore pressure difference, there is a flight. Okay, so that means flight in the sense that there will be a lift to that wings to that aeroplane, and aeroplane is going to get fly in the air. So that is the principle of Bernoulli's theorem has been used here in case of your aerodynamics or in the wings of aeroplane or aerofoil. Okay, so these are the different applications are there. This is a very important application, so therefore I have kept separately for the explanation point of view, so that the students will get the idea about what is exactly Bernoulli's principle has been used in different places. Now I will take the two problems, and so that you will get the idea how the Bernoulli's principle can be used. Okay, hope so you understood that how the aerofoil or aerodynamics, the Bernoulli's principle has been used. Okay. Now once you got that things, then you can take the example for that. So the first example is, write down, calculate the pressure exerted by mercury column, calculate the pressure exerted by the mercury column of a height 20 centimeter, okay, pressure exerted by the mercury column of height 20 centimeter, The density of mercury is 13.6 gram per centimeter cube. 13.6 gram per centimeter cube. Okay. And the G is 9.8 meter per second square. G is 9.8 meter per second square. And what he has asked you, calculate the pressure exerted. P will be how much? So now, you know pressure is equal to pressure due to height. So that formula you know, that is equal to H rho G. What is the formula? H into rho into G. So now here this is in meter, this is in centimeter. Do everything is meter. 0.20 centimeter means 0.2 meter, because 20 divided by 100, that is 0.2 meter. Then rho density will be 13.6 into 10 raised to gram per centimeter means 10 raised to minus 3, 10 raised to minus 6, minus 3 plus 6, 10 raised to plus 3. Okay, and G will be 9.8. So if you can calculate all this calculation, 13.6 2s are 12, 1, 3 2s are 6 plus 1 7, okay, and 2 1s are 2, okay, means that your answer will be 1 2, okay. So that answer will be 2.72, okay. 13.6 means 2 point, okay. Again I'll calculate. So this will be the 136 into 2, 272, 1 to 2.72 into 9.8 into 10 raised to 3. So if you do that calculation, so if I'll take that 10 also, 2.72 into 10 raised to 4, okay. Or we can also say this calculation, if I'll just say that will be approximately 10, then 27.2 into 10 raised to 3. Okay, so that will be the approximate, that is it. And correct answer is, your answer is 26.66 into 10 raised to 3 Newton per meter square. So that will be the pressure exerted. Okay, so this is your correct answer. Okay, so that how we have to calculate that pressure. Now next question we can take, okay, by using the Bernoulli's principle, how to solve this problem. Okay, so write down next question. So the horizontal pipeline of uniform cross section pressure falls by 5 Pascal, means he has given to you P1 minus P2 is equal to 5 Pascal. Okay, what is that? 5 Pascal. And now between the 2 points separated by 1 kilometer, okay, so in between the 2 points that separated by the 1 kilometer, the pressure falls P1 minus P2 is किती दिले मुलांनो 5 Pascal. And this is the horizontal pipe, so therefore height will be 0, okay. And then next, what is the change in kinetic energy per kg? What you want to find out? Change in kinetic energy per kg. Okay, what will be change in kinetic energy per kg of the oil flowing at these points? Okay, and density of the oil he has given to you. Density of the oil is how much he has given? 800 kg per meter cube. How much? 800 kg per meter cube. 800 kg. Okay, first of all write down that number, 800 kg per meter cube. So that is the change in kinetic energy. That is the density of oil, and you want to find out this factor. Now what I will do, I have the relation of kinetic energy per unit mass. Okay, what is that kinetic energy per unit mass? So that means kinetic energy, Bernoulli's principle is telling, according to that, kinetic energy per unit mass 1/2 किंवा आपण एक बघू, प्रेशर एनर्जी पर युनिट मास, मग PV upon m, म्हणजे काय रे हाय, V velocity volume upon m, mass upon volume will be density, P by rho. Okay, this is the pressure energy per unit mass. Then kinetic potential energy per unit mass म्हणजे mgh, म्हणजे mgs चा m get cancel, gh. And last but not least, kinetic energy per unit mass. Okay, means 1/2 v square. 1/2 v square is equal to constant. Okay, हे रिलेशन आहे. आपण दोन पॉइंटला टाकू मुलांना. पहिल्या पॉइंटला आपण टाकूया प्रेशर P1 अपॉन रो प्लस हॉरिझॉन्टल पाईप आहे, H 0 झाला, चला ठीक आहे. half V1 square is equal to constant. First point. Second point, P2 by rho plus 1 half V2 square is equal to constant. मुलं दोघं इक्वेशन आपण इक्वेट करून टाकू. मग आपल्याला इक्वेशन मिळतं काय बघा रे. P1 by rho plus half V1 square is equal to P2 by rho plus half V2 square. ओके. मला आता काय काढायचंय मुलांनो, कायनेटिक एनर्जी पर युनिट केजी. मग मी आता इथे एक काम करतो, P1 मायनस P2 हा इकडे आणतो बाय रो, कारण हा इकडे आणला तर रो कॉमन 1 बाय रो P1 मायनस P2 इज इक्वल टू 1 हाफ V2 स्क्वेअर मायनस 1 हाफ V1 स्क्वेअर. मग मुलांनो मी जे याला m ने मल्टिप्लाय केलं आणि डिवाइड केलं आणि डिवाइड केलं आणि कट नाही करणार, याला राहू दे. म्हणजे 1 हाफ m v2 स्क्वेअर म्हणजे काय येणार रे, 1 हाफ m v2 स्क्वेअर मायनस 1 हाफ m v स्क्वेअर म्हणजे चेंज इन कायनेटिक एनर्जी. आणि हा मास आपण केजी मध्ये टाकू, पर केजी इज इक्वल टू P1 मायनस P2 अपॉन रो. P1 मायनस P2 आपल्याकडे दिलेला आहे मुलांनो 5 पास्कल आणि डेन्सिटी सुद्धा त्याने दिलेली होती 800. मग उत्तर किती आलं रे, 5 1 जा 5, खाली राहिले 3, 5 6 जा 30, 1 by 60. ओके, 1 अपॉन 1 by 60, 1 अपॉन 1 by 60 म्हणजे मुलांनो 6.25 इंटू 10 रेस टू मायनस 3. 6 पॉइंट. हे बघा हे कसं काढलं माहिती आहे का मुलांनो, 1 by 60 इंटू 10 दॅट इज इक्वल टू 0 16 16 96 काढायला 4 16 32 16 85 आणि अपॉन 10 म्हणजे हा 10 रेस टू मायनस 1. मी याला काय केलं मुलांनो, याला आपण असं लिहिलं 6.25 म्हणजे मी जर याला 10 ने मल्टिप्लाय केलं 10 ने डिवाइड करावं लागेल म्हणजे 6.25 इंटू 10 रेस टू मायनस 2. ओके, 6.25 इंटू मुलांनो आता 1 मिनिट 1 by 16 ना म्हणजे 0.0 होतं ना मुलांनो, 0.0 कारण 0 आणि हा जो भागात 0 परत 10 घेतला 16 96 म्हणजे मुलांनो 6 इंटू 2.5 इंटू 10 रेस टू मायनस 3. आणि हे किती येणार, चेंज इन कायनेटिक एनर्जी म्हणजे जूल आणि पर केजी. ओके, जूल पर केजी. सो दॅट विल बी द your right answer. Okay, so this is way how you can solve these numericals also. 6.25 into 10 raised to minus 3 is the right answer. You can solve this type of sum. So this completely finishes your friction in solid and liquid. Okay, that is the end of the topic with numerical. Okay, thank you. Sure.